Hello. The next here we taken the extended part, that is the GSM and CDMA. That is the part number 3. Already we seen the in previous related to all the details of the GSM and architectures, some details parameters of the GSM standards, history, all that things we seen up to the part 2. Now we extend the part of GSM and CDMA part number 3, and let us talk about the extended part, that is the common control channel. There are three categories, that is RACH, or we are calling random access channel. Another one access grant channel, that is the ACH, and paging channel, that is the PCH. If you talk about the random access channel, it is the uplink portion of CCH control, CCH control channel, and it is accessed from the mobile station in different manners. So these are the common control channels. The access grant channel is the downlink part of the CCH. The paging channel is part of the downlink of CCH and is used to page in order to find specific mobile station. When call is initiated, when call is initiated. Talking about the dedicated and associated control, we have dedicated control channel, the slow associated control channel, and fast associated control channel. These have different specified utilities, and these are being listed here. The details can be found out from any standard textbook related to GSM. Now we move over to the modulation for GSM. This is the modulation of GSM. In previously we seen and discussed about the some GMSK and other standard modulation techniques. Here we mentioned it is useful for GSM, that is the Gaussian minimum shift. Here is the, don't take the different global shifting model. Here is the Gaussian minimum shift, that is the GMSK for modulation. Let's we check the, and this is the some revised and it will be uses for the Gaussian minimum shift keying for modulation. We have seen these already in before. GMSK belongs to a family of continuous phase modulation procedures. And what are the advantages? We mentioned here narrow transmitter power spectrum with low adjacent channel interference, and it's a constant amplitude envelope, so you can use a cheap class C amplifier. So GMCK modulation consists of minimum shift key procedure, and the data is filtered through Gaussian LPF. The power spectrum of the signal becomes narrow, and individual impulse response are mentioned, and it's The bit duration leading to some symbol interrupts. To overcome this ISI equalizer have to be used at the receiver side, and it will be shown in as well I discussed in previously. And there is some phase and quadrature components for the multiply by GMSK, and details of these has already seen discussed when we talk about the GMSK modulation techniques. Now let us talk about the multiple axis for the GSM. GSM uses a combination of FDMA, that is and TDMA. The two frequency bands almost, that is the 45 megahertz apart, have been reserved for GSM. One is the 890 megahertz for the uplink and 935 to 960 megahertz for the downlink. Each of these band is 25 megahertz, then further subdivided into 120 per single carrier channels of 200 kilohertz. Now each of 200 kilohertz channel carries 8 time division multiple axis channels, that is 8 time slots. That is the 8 time slots, that is the TDMA frames. Now the TDMA frames of the uplink are transmitted with a delay of 3 time slots. The mobile station uses the some time slot in uplink and downlink since it does not send and receives in the same time slot. And each TDMA frame lasts 156.25 beta times, and it used a condenser data burst. There are also some types of burst. It is actual details given in different university curriculums, and it is some research oriented parts of bursts. But this is the part of GSM and CDMA. Hence, we taken here. You see the details, the types of bursts. When we talk about the burst, we are talking about data burst. We have the normal burst used to transmit information on traffic and control channels, and we have frequency corrections burst used for frequency synchronization purpose in it for the mobile station. Then we have synchronization burst. The third one, it is the used for the time synchronization of the mobile station. And also we have a dummy burst that is related to BCCH carrier and enables uh, mobile station to perform some power measurements. You also have an access burst used for random access without any reservation. You can have these kinds of data transfers and being labeled differently depending upon the some applications. So whenever you get a time slot in the TDMA, you send out a burst which could be of any of these types. Let us go back of the some frequency allocations plan. We know already that two frequency bands of 25 megahertz in each one have been allocated in GSM. In the 890 to 915 has for the discussed before already, and 935 to 960 megahertz but not all the countries can use the whole GSM frequency bands. This we do principally for military reasons. Here you mentioned it here, and to existence previous some analog using part of the 25 megahertz frequency band. So this is what is in the standard depending upon individual countries. Part of the bands may be used. Now we know that the mixed frame and TDMA is being used in GSM. Now let us going ahead and related to services being provided by the GSM, because standard also tells you what are the different kind of services which can be obtained using the kind of network. The telephone is what is started, so but when we can also send group 3 packs, you can make emergency and SOS calls. This is the most popular one, the short message service for SMS. Using this services, message of maximum 160 alphanumeric characters can be sent or received, fax mail, voicemail. So all of them are being laid out in the GSM standard, depending upon a network operator. And any network that is implemented in the GSM, they can send them more than 160, and it is the not in standard, but still questions being raised is can any network which is using GSM standard give you an SMS facility which is not for a short messaging limited to 160 alphanumeric characters. This is the some GSM services, telephony, smile groups, emergency calls, short messages. Already you know, maximum 160 alphanumeric characters can be sent or from mobile station, fax mail, or voicemail, and it is the spread across the globe. And now steps we have been taken to convert this 2G standard in to 2.5G, then 2.75G. So GPRS and Edge are the steps in those directions. Clearly, there are some certain disadvantages of GSM, which will given in details. It can go up to 2.75 and beyond, but it will never touch the 3G standards. Let us see what are the disadvantages of the GSM. First of all, it is slightly wasteful in terms of multiple axis. Each radio channel uses a frequency guard which is inefficient. Then we have seen that complex frequency planning is required to avoid to co-channel, and that is the ACI, that is the adjacent channel interference. In the earlier part of this course, means earlier part of this some parts, that is one, two, three. We had sort of spending some time talking about the some frequencies, some frequency planning, some cluster size, and how the capacity of the cellular system depends on and how close your reuse frequency. And but as you reduce the reuse distance, you start getting a higher and higher co-channel interference. And we also have the provision of self-splitting centralization, but again the complex frequency planning and certain radio channels are unavailable due to some interference standard problems. And then again, since it uses some combinations of FDMA and TDMA, we have to give some time slots as time guards. So every time slot has to have a guard band before and after, so that you don't and go to the next adjacent time slot. This is again inefficient. The time slot is occupied when there is a pause in the speech when we talk about the CDMA standards. And we will see how the pauses of the speech are used to send data for somebody. Let us now quickly go over the third generation debate, which was very emerging topics some 2 years ago. It's kind of being settled, but for the sake of posterity, that is the understand purpose. And the main purpose of third generation mobile system is provide some greater system capacity. And it is basically centers around the proposed standard CDMA 2000 and WCDMA. And today we know both coexist and we don't converge one world standard. However, the general multiple access scheme has been finalized. We'll see in our lectures during the CDMA 2000 WCDMA that are not many significant differences between these two standards. Now let us go to the some Shannon's theory, some related to system capacity. Shannon's theory predicts some maximum amount of information that can be transmitted over any channel with given bandwidth, and SNR is given as a C equal to some blocks. So the capacity C grows linearly with bandwidth and logarithmically with SNR, that is the SNR bandwidth. So the optimal usage of given bandwidth is obtained, and maximum SNR is maximized at the receiver side. Hence we know that if you have any the axis in SNR, then with the capacity grows in some logarithmically with SNR. And if you plot on this axis bandwidth, then the capacity grows linearly with bandwidth. And this is the idea how system which uses some large bandwidth and lower SNR almost. That is answered by the CDMA which uses excess bandwidth over and beyond. This is some system capacity related data. This is totally related to some GSM, introducing of the GSM and details of the GSM, and all about the data will be given some. Now we see the next lecture, that is we'll try talk about the some CDMA, how CDMA is offered and how it is the more efficient than GSM, and how CDMA system works and what is the advantages disadvantages behind. And when we look ahead the 4G generation of mobile system. Now we conclude here the GSM part. We'll stop here. Afterwards we see the some CDMA part. Thank you.